Good evening, everybody, and thank you for being here tonight and to give me the opportunity to share with you some thoughts on the CAD/CAM fabricated complete dentures. Before I start, I just want to thank Ivoclaw Vivadent for their support, and I just want to also thank Mr. Lee Culp, CDT, who's an amazing dental technician who's did 99% of the work that you're going to be seeing tonight. Before I start, I just have a disclosure that the statements of fact and opinions are my responsibility alone and don't imply any opinion on the part of the officers or the members of the American College of Prosthodontics. And the reason why I'm saying that is because presently I'm the president of the American College of Prosthodontics. And this presentation, as I said, is supported by a grant from Ivoclaw Vivadent. The objectives of my presentations are, first of all, to learn how to utilize analog procedures to transition into a digital workflow. What I'm going to also do is determine how the digital denture try-in can create the final clinical records. Discuss the unique tools to aid in creating a digital tooth setup. And finally, describe briefly the principles of complete denture occlusion. Now, we all know that patients are getting older and we have an aging population that is growing in size since the baby boomers are reaching the age of retirement. We also have a rapidly increasing patient base. Patients are getting older and we're getting more of them in the office. And there's also an increased complexity of patient care. These patients, when they were 50s and in their 50s and 40s, they had money, they were working, they had partial edentulism here and there, and they had some implants. Now they are at 80s and more, and the implants are still there while their natural teeth are given up. So this has created a little bit of a challenge in treatment planning. And on top of that, there's an explosion of modern technology. Now, we've noticed recently the CAD/CAM is not only in fixed prosthodontics, maxillofacial implants, and now it's in removable. So it's here to stay, and it will be a long time. And we're going to see a lot of new technology coming out through the years and to benefit our patients and make our life easier. Now, complete edentulism is not going to disappear. People thought for a while that, we're not going to do dentures and we don't need to learn it in dental schools. But unfortunately, if you look at the WHO, which is the World Health Organization, they classified edentulism as a major public health problem. If you look at the table here, they classify it as a disability number 2. And because it fulfills the World Health Organization definition of a physical impairment, the disability, and a handicap. Worldwide, the percentage of people between 65 and 74 that have lost their teeth, according to WHO, varies between continents. And you can see the percentages vary from continent to the other. But what's important to know is that more than 260 million are partially and completely edentulous. This is a study published in 2002, and at that time, a colleague of ours wanted to find the need for complete dentures in the United States in 2020. So what he concluded is there is an increased aging population. Approximately 37 million of our patients, of our population are edentulous. And there's a continued growth of edentulous patients. There is an increased demand for complete dentures in the next 30 years. So edentulism is going to be more widespread. It's going to remain a challenge, and it's a growing public health concern. We all know that when you lose teeth in the maxilla, there's changes in aesthetics. There are some microscopic changes due to residual ridge resorption and some microscopic differences that are associated with bone density. In the mandible, when a patient loses their teeth, there is a loss of retention and stability. There is continued bone resorption and a poor masticatory function. And something important to remember that when a patient loses their teeth, in the maxilla shrinks centripetally, and the mandible augments in size, gets larger. Now, let's look at some clinical facts regarding complete edentulism. Now, this is an old study that published in 1983, and they wanted to look at the successful treatment outcome with mandibular complete dentures. They found that the residual ridge form and anatomy are correlated with the retention and stability of the denture. They found that a stable mandibular denture was the most significant factor in determining patient satisfaction. So if a patient is satisfied and is confident and has some improved perceived comfort, then you have given them the ideal treatment. Same study in 1983 looked at some factors that can contribute to the success of complete dentures. They looked at some biologic factors, some physical factors, and some mechanical factors. But what they found is that many factors are implicated in the satisfaction of a complete denture wearer, not only one. The residual ridge form in the mandible and the jaw relations has been shown to be important. What happens to the chewing efficiency when somebody loses their teeth? Studies have shown that there is a decrease of 1/4 to 1/7 of chewing efficiency depending on age and the type of food. It will take up to 7 times more chewing strokes than dentate subject to reduce food to half of the original size. But fortunately for us, that only 5 to 20% of patients are not satisfied with their dentures. How many times we've seen patients wearing very old dentures that 30 years plus, severely worn down, broken, ugly, they smell bad, and they don't see the need to change them. So these patients suffer with problems such as the inability to chew tough or hard foods. They have oral pain or instability of their dentures. These are studies that show that there's a fundamental need for the well-fitting dentures. There is a reduced number of teeth, and if somebody loses their teeth, this leads to a decrease in the oral health-related quality of life. A study published in Saudi Arabia by a colleague in Saudi Arabia, she looked at the quality of conventional complete dentures versus the quality of life. And what she concluded that denture stability in both arches significantly affected the patient's quality of life. So what has been done to enhance stability and retention? Through the years, people have tried different techniques. One of them was bone grafting and just skin grafts. And some other people have tried to use these prong dentures where in the anterior area of the denture, 2 little fingers made of plastic were introduced into 2 little notches that were created in the vestibule under the nose. And these little plastic prongs would go into these notches to create some retention. Some other people have used these little pins, and I think these are kind of a torture for the patient. Well, the principle of these is that creates some irritation, which causes the gums to swell and hook up around these. This is really, it's a torture. Now, some other techniques were to use overdentures on natural teeth. Now, they did work perfectly well, but the problems with these is that patient needed to have root canals. They had some caries around the abutments, and sometimes the abutments themselves broke. Finally, the introduction of implants has improved very much the way we treatment plan and we service our patients. And it had provided our prosthesis with an ideal tool to get stability and retention. Now, when it comes to material itself of making dentures, different materials have been used through the years, ranging from ivory to wood to porcelain to vulcanite. And it wasn't until 1930 that metal methacrylate was introduced. And since then, 90 to 95% of complete dentures have been made using this material. The problem with polymethacrylate is that they have a lack of intimate fit because of the net volumetric shrinkage of about 6 to 7% of the denture base. There's also some remaining of residual PMMA that could cause some allergies to some patients. There is a need for 4 to 5 appointment visit. Now, some people have managed to make them 3, but the majority uses 4 to 5 appointment visit. There's the inability to create a duplicate denture. Now, if a patient goes to the hospital and then by mistake, the hospital throws the dentures, and there's no way we can duplicate it. We have to remake another one. And there's also some studies that shown that Candida albicans adheres excessively well to polymethyl methacrylate, which causes some soft tissue problems and sometimes some health problems. So why digital dentures? The problem is, clinically, denture making takes time and experience to master. Now, we all know that it takes us many sets of dentures when we started dentistry or practice of dentistry to kind of master how to fabricate complete dentures. There is a shortage of qualified dental lab technicians, and there's also a lack of adequate experience in dental schools. On the lab side, there's a processing dimensional changes due to the shrinkage of polymethyl methacrylate, which causes retention and stability problems. And also some occlusal inaccuracies, because when you process the dentures, not only the base shrinks, but the teeth also move. It's a time-consuming lab remount. It's a lab-consuming procedure. And also in the lab, there's also a need to do a clinical remount to adjust the inaccuracies in the teeth, in the occlusal movement due to the teeth movement. So traditionally, the material, the PMMA, cannot withstand the stresses of implant-based denture. So there was a need to create something that is stronger and that could take the load that is created by the implants on these materials. So the success of CAD/CAM fixed and implant in maxillofacial prosthodontics, along with the shortage of qualified dental lab technicians, have pushed us to go into digital dentures. According to the Glossary of Digital Dental Terms published by the ACP, digital denture is defined as a complete denture created by or through automation using CAD, CAM, and computer-aided engineering in lieu of traditional processes. Now, if you look at the history, since 1994, there's a lot of publications that were done. But at the beginning, they were all lab studies. Now, they were either milled modeling wax, milled titanium, 3D laser lithography technique was used. Some of them used computerized numeric control machine and a laser rapid forming system to kind of find out how we can digitize complete dentures. All were lab studies up until 2010, when my colleague and mentor, Dr. Charles Gureca, was the first one to publish a first clinical trial placement performed using a CAD/CAM proof of concept denture-based mill from Lucite. What he did is he made a traditional nutrocentric impression, and then in the patient's mouth, he marked the midline, he set up the teeth, and grabbed the centric relation record. So that's all what is needed to help somebody fabricate a CAD/CAM denture. Then he sent that to a friend of his that had not a 5-axis milling machine, it was a 3-axis milling machine at that time. And then his friend helped him mill the dentures out of a lucite block. The problem is that the block wasn't thick enough. That's why if you look intraorally, there was a missing all the papilla area haven't been milled because that block was excessively short. But at least he got the okay that it's the proof that this concept works, that CAD/CAM dentures are possible to make. And it wasn't until 2012 he published another article in the Journal of Prosthetic Dentistry, where this time he had the denture bases milled from polymethyl methacrylate and the teeth bonded manually. It was the first denture that were ever placed in a patient. You can see here the block was fabricated by Dr. Greco himself. They were not fabricated under severe pressure, under like 5 or 6 bars of pressure, and it wasn't a very dense material, but he just wanted to make sure that this concept works. This is the first denture that was milled, and you notice that this is as milled, and it was milled in a 5-axis milling machine. You can see the smoothness of the surface, and that was a proof that the concept works. Look here, the denture has no polishing, and it looks very smooth and nice. This is how it was delivered to the patient. The patient still wears the dentures up to today, and she comes for frequent visit at Loma Linda. On the market, there are 7 systems that are available to help you fabricate CAD/CAM dentures. It's the Avadent Dentsply Sirona system, the Pala system, the Amann-Gebach, Vitavionic, Baltic Denture system, the Dentka, and the Ivoclar Vivadent. Tonight, because of the shortness of time, I'm going to only focus on the Ivoclar Vivadent system. The Ivoclar Vivadent system is a customized digital solution. It's a fully integrated digital workflow, and it's a standalone complete laboratory system. Your lab controls all the milling and the fabrications of the denture. Now, the system is indicated for complete dentures, single arch complete dentures, and immediate complete dentures. Let me give you an idea how the Ivoclar Vivadent complete denture digital workflow works. What you can do is you can have a 2-appointment workflow that if you're doing immediate dentures. The way it works, in your first appointment, you grab an impression, send it to the lab, along with the biter station, of course, and send it to the lab. The lab will design, will mill the dentures, will bond the teeth, and then what they do is they send it back to you for your trial seating. So what you have to do is extract the teeth and deliver the immediate denture. The 3-appointment workflow uses a combination of analog and digital. Here, what you want to do is you can, if your patient is wearing his existing complete dentures, what you do is use these, duplicate them, and use them as a custom tray. So what you do is you border mold maxillary mandibular and grab a centric relation record. That's your first appointment. Along with some other data that you have to collect, you send it to the lab. The lab will design the dentures virtually, share it with you, you approve it. What they do ahead and send you a trying denture that could be either printed or milled. And that's your second appointment. You try them in the mouth, do the adjustment, check the vertical dimension of occlusion, the lip support, phonetics, aesthetics. And if the patient is satisfied, what you do is you have your lab technician then keep working on it. They mill the base, they bond the teeth, they finalize the denture and send it to you, and that's your third appointment. The 4-appointment workflow is a fully digital workflow. Here, what you have to do is grab some impressions. They could be either alginate impressions or an impression that you made, and then you put the cast, so you can send the cast to the lab, along with the centric relation record. And some other data like the papillometer reading and the inter-alar measurement. And I will show you in details some cases to go over all of these workflows. You send all the information to the lab. They will design for you a 3D bite plate. Now that 3D bite plate is of course fabricated at a tentative vertical dimension of occlusion, and the bases are not accurate since the impressions that you send are alginate impressions. So you're going to use these to use them as custom trays. You're going to border mold them and grab a definitive impression with these. Then you're going to use a gnatometer to record centric relation. Once you have all of that, that's at your second appointment. You're going to also determine the midline and the lip line, the smile line. And then once you have all of this, then the lab is going to fabricate for you a trying denture. That could be, again, either milled or printed. Now, you try it, you do all the adjustment if necessary, and if you're happy, the lab will then mill the base, bond the teeth, and send you the dentures for delivery on your fourth appointment. Let me show you some examples. This is a 2-appointment workflow for immediate complete dentures. You can see here the 2 options. You can either grab some excellent alginate impressions, but you want to grab of the borders as much as you can. But the lab technician can't do miracles if you don't have an impression that is accurate. Or you can do a polyvinyl siloxane impression. That stage, once you said that, what they do is they take the data, they design the dentures, they do the virtual surgery on the cast, they share that with you, and then once you approve it, you go ahead and mill the dentures and send them to you. Let me show you some cases. This is the first patient, 54 years old, male. It has maxillary and mandibular partial edentulosum, capario disease, and a class 3 tooth mobility. All his teeth needed to be extracted. 2 concerns he had. He wanted to preserve the anterior overlap between that he had on the laterals and centrals. So he wants 7, 8, 9, 10 to be in the same position of his natural teeth. And we needed to preserve the video because the video was correct. So What I did here is I decided to go with ICD over ICD. We made some alginate impressions and centric relation record. Now I sent the whole thing for Lee, and what Lee Karp did is did surgery, a virtual surgery on the cast, and then the teeth were set up according to some anatomic landmark requested by the software, the 3Shape software. And then here you can see a superimposition of the existing dentition and the shape of the dentures, how it's going to be at the end. Now here you can notice that the 4 incisors, 7, 8, 9, 10, are exactly positioned the way the patient had them in his mouth. In the end, the remaining teeth are set according to some anatomical landmark that we all know and then that we have followed for many years when fabricating removable complete dentures. Occlusion is worked at that stage. Here we ask for lingualized occlusion. You see the contacts are worked out very properly. And you can see here how aesthetically the teeth are going to be. Once we have that, now I approve the design. And then what Lee does is he goes ahead and mills. The teeth are milled separately and the base is milled separately. And the teeth is bonded to the base. And then once they bonded, the dentures are remilled and finalized. And this is how I receive them. All what I have to do is call the patient in, extract his natural teeth, and deliver the ICD. This is just after the delivery. You can notice the aesthetics of these dentures, occlusion, and all what you need to have to get a beautiful complete denture. This is another case. This is a single arch. You get a 56-year-old male presented with maxillary and mandibular partial edentulosum. He has a collapsed vertical dimension of occlusion and trauma from occlusion all his anterior teeth, along with some caries. So what we decided to do is extract all the maxillary teeth and deliver an ICD. Well, we needed to raise the vertical, change the teeth, form and shade, but the most important thing is to preserve the midline. So the first thing I do is just traditional definitive impression for an ICD. I use the Wagner trays that mold them chair side, then go in the mouth, mold the tray, and then what I do is I do a border molding and a definitive impression using the PVS. Then what I do is once I put my cast, I fabricate some base plate and wax rims, and I position them at the exact vertical that is desired, and I take a centric relation record. Now, this will make it easy for the lab technician because they can open the vertical on the software. So this way, the vertical is open to exactly what I wanted, and the lab technician is going to position the future teeth where they need to be according to that vertical that is provided. A good option also is to provide the lab with a photo of a patient before he lost the teeth. Now here, the casts are virtually mounted. The surgery is done virtually also, and the teeth are set up. Now this is shared with me through TeamViewer, and then once I approve it, what the lab technician goes ahead and finalize the denture for me. And then I call the patient back, extract the teeth, and deliver the ICD. And notice the beauty of CAD/CAM is that the teeth are in one piece. There's no voids between the teeth. The teeth are strong and they aesthetically look very pleasant. Now, because of the Ivoclar library is provided here for the teeth, so you can either have Blue Line, you can have Phoneris, you can have SDCL, so you can pick whatever you want from the library. The 3-appointment workflow is a little bit different. Here, what you can do is, if a patient is wearing the complete dentures, you can duplicate them and use them as a custom tray and then go from there. What you can do also is grab 2 alginate impressions and a centric tray. You can use some casts of previously poured definitive impressions and a centric tray that the lab technician can scan, or you can just fabricate conventional base plate and wax rims like we all do when treating complete dentures patients. So there's really nothing new in there, and the flexibility that you have in that system is excellent, because it gives you the ability to do whatever you're comfortable to do to get an excellent denture at the end. Then the lab technician is going to send you a try-in denture, either printed or mailed, depends on the lab, and it depends also on your preference. You try them, adjust them if needed. Sometimes if the intaglio surface of these try-in dentures is, let's say the flanges are short, you want to extend the flanges here and there, or what you want to do is, let's say, posterior palatal seal area is short, you can extend these and make a wash, and the lab technician is going to scan that intaglio surface and make it your new base for your future denture. And then once you approve all of this, they go ahead and send you the definitive denture for you to deliver. So this is the first case with a 3-appointment workflow. A patient is 66 years old, had extractions done and immediate dentures delivered. I did the work myself, and patient was very happy with the dentures. The only thing is just they're not stable anymore, and they need to have some stability and retention. So we decided to go ahead and make new dentures. And since I have made the ICDs, and then I knew that the vertical was correct, he liked the phonaris teeth, he liked the midline, and he likes the aesthetics. So we decided to preserve tooth mold and shade, preserve the vertical dimension of occlusion, and preserve aesthetics. So what we decided is duplicate his dentures and use some adhesive painted on the duplicate, and use some PVS. In this case, I used the Virtual XD from Ivoclar, but you can use any PVS of your choice. Then you do a bono molding with the heavy body, and you do a definitive impression with the light body PVS. And this is how it looks like. Now what you do is you put that in the mouth, and you grab a centric relation record with a PVS bite restoration material. Then you send all the material to the lab along with the bite restoration. And then what they do is they're going to scan the intaglio surface of the dentures, and using the duplicates, because this is what's going to provide the vertical dimension. So it's going to set the occlusal plane. Then some selected landmarks are determined, and this is what the software asks you as a lab technician to do, and it's a checklist. You have to go through that. Once this is done, you're going to determine the outlines of the maxillary and mandibular dentures. At that stage, the software is going to ask you to pick up from the library of teeth. What you can do is either go with Blue Line, Phonaris, or Vivodent SDCL. In this case, the patient had some Phonaris teeth and wanted the same teeth shape and mold. And that's why I decided to keep the same thing, and we went with the Phonaris teeth. Once the teeth are set up appropriately where they need to be, the base is added and is sculpted and adjusted. And at that stage, what needs to happen is that the software is going to adjust the occlusion. Now, this is what we call adaptive occlusion, because the software is going to balance your dentures. So you don't have to really do it yourself. So everything is done virtually. So once these are balanced, now all what you have to do now is when you mill them, the dentures are already balanced. And then when you deliver them, you can do some minor adjustments if needed. At that stage, I asked Lee to send me a milled try-in denture. Now, you can notice the disadvantage of these is that they're extremely white, and the patients have a little bit of difficulty looking at the dentures and trying to find out what is he looking at. Now, effectively, this is what they've been looking at. The only concern they have sometimes is, are my teeth going to be that white? Well, the reality is no, but you just tell them that this is just to give you an idea of the position, of the shape. And then what you can do also is take a disc and individualize these teeth to make them look much more vital and natural. And you tell them only that the shade is going to be a little bit different. Now, in that case, sometimes you have to adjust the occlusion. And if you notice here that I adjusted the occlusion on the upper right side, what does that mean is now I have changed what Lee has provided me. And all what I have to do to correct that is grab a centric relation record. And what he has to do now is to scan the cameo surface of the dentures where the teeth are, and where I adjusted the occlusion, and then remount that virtually and take it from there. Now, what are the materials that they're going to use? Now, for the base, there are 4 different shades. Now, for the teeth, there are 2 kinds. There's the Vivadent CAD, which is a monolithic color, and there's the Vivadent CAD Multi, which is a layered color. This is a more vital block that will give you a very good looking teeth with an incisal translucency. And let me show you, I will show you some examples. This is the SR Vivadent CAD Multi, and you can notice the translucency on the tip of the incisors. Now, of course, the library that you see here, this is the Ivoclar property. And these are the exact same mold of the carded teeth that you buy or the lab technician buys to do your traditional dentures. But if you look at the quality of the teeth, these are the SR Vivadent CAD, and this is the SR Vivadent CAD Multi. You notice that here there is a monochromatic shade, and then when you look at the CAD Multi, you can see that the incisal had a certain translucency that gives the tooth some vitality and make it look natural and pleasant. And this is the phonaris, and you can see the resemblance between the carded phonaris teeth and the milled CAD Multi teeth, and you can see how nicely they look and how aesthetic they look. Let me show you intraorally how they look. The maxillary denture was done using the SR Vivadent CAD Multi Shade A2, and the mandibular denture was done using the SR Phonaris A2. You can see here the beautiful translucency that you get when using these CAD Multi blocks that are very similar to the SR Phonaris teeth. Now, if I hide these two and you don't know which is which, you wouldn't even tell. And look how beautiful and natural these teeth look. So once you've approved the design, and you've approved now the shade of the base, and you decided what type of shade of teeth and mold you want, what the lab technician is going to do is to pick up the block for the base. It's going to put it in the machine, and they're going to do 2 things. They're going to overmill, if you can look here, overmill the base and the teeth. And you notice the dentures are not milled to completion. They are overmilled. They are oversized milled. Why? Because look, the teeth are going to be milled to completion only at the base surface. Look at the anatomy, and the surface is not milled to completion. Now, this is the teeth. If you look at the base is not milled to completion except for the sockets that are going to receive the teeth. So again, the teeth are milled to completion only in the base, and the base is milled to completion only in the sockets where the teeth are going to be seated. Now, the next step would be to take a bonding agent, which is the Ivo-based CAD bond. And then what you're going to do is you're going to bond the maxillary teeth to the base. And then once you do that, you're going to take the whole thing and put it in a pressure cooker for 20 minutes. And after this is done, you take that puck again and you put it in the holder, and then you go ahead and seat it back in the PM7 machine. And now the dentures are going to be milled to completion. The completion, the anatomy, the morphology of the teeth, and the denture base itself. Once they are milled to completion, the lab technician is going to receive them like that. And you can see the beauty of the surface, very smooth and nearly done. So all what you have to do is cut these screws and clean them. And I personally use these rotary instruments. The first one is to cut the screws. And then what I do is I grind them, pre-polish, and polish the area. And at the end, what I will do is I take a buffing wheel and some buffing agents and finalize the polish. This is how they look like. They're very nicely polished. You notice that there's no voids between the teeth. The teeth are in one piece, and they bonded to the teeth, to the base. I'm sorry, they bonded to the base. And you can see here the natural appearance of these dentures and how nicely they look. Again, the adaptive occlusion has been done. So the dentures should be balanced at that time. So all what you have to do is go to the trial appointment and then adjust them, do some traditional PIP just to find out if the dentures are of the bases are fitting properly. And you just check the occlusion. If some adjustments are needed, you can do them. This is another case that uses a 3D three-appointment workflow. 75-year-old female, have immediate complete dentures. Midline is off. Maxillary complete dentures was broken. So she wanted to change the teeth mold and shade, and she said, I look very old with these, and I want them a little bit lighter, and I want the teeth shape to be a little bit younger. The good thing is I needed just to preserve the vertical dimension of occlusion. So what I did is, again, I duplicated the dentures, did a border molding and a definitive impression. And at this stage, I need to provide the lab technician with some measurements here, because we're changing the teeth mold and shape. And so what I do is I provide him with the papillometer reading at repose, which give me the position of the incisal of the teeth. Then I'll provide him with the papillometer at smile, which provides me with the position of the neck of the teeth. And then I provide the lab technician also with the inter-ala measurement. And this will provide the size of the mold of the teeth to be used. This is what I sent to the lab. See, I changed the midline because the midline was off. Now I have a centric relation record and definitive impressions. So that's all what the lab wants. We're not changing the vertical, so we're preserving that vertical. The only thing is the midline, the shape of the teeth, and the form of the teeth needed to be changed. So when he puts everything in the computer, you notice that there's like a marker here that he sets close or just on top of the midline that I have provided, the new midline. And then the teeth are set, and then the occlusion is worked out very delicately. And then we go over every single tooth, make sure that the contacts are there and the dentures are balanced. And then what you do here, you can evaluate the overjet, the overlap. You look at everything. And then once the teeth set is and you're happy with it, and you give him the approval, then he puts up the base, and then he sculptured the base to make sure that the dentures are going to look natural. Now, of course, after the dentures are milled, what Lee does is he adjusts the shape of the base and sometimes a little bit the shape of the teeth to make them look even more natural than they will be after they're milled. What he does is he sends me a printed try-in denture. The reason why I like these is you can have the patient take them home. In that particular case, that patient wanted to have it to go home to show it to the kids, because her kids live a little bit far away and they only come on the weekend, which is good. So I left it to her, and then after the week, she came back and she said, I like it. So I call Lee and I have him finalize my dentures. Then once they're done, patient comes back, and then we deliver it. Now at this stage, again, traditional PIP, paste application, check the bases, check the occlusion, and then if there's nothing needed, that's fine. I mean, and then hygiene, instruction, and maintenance. So this is before and after. You can see here, I was able to provide her with what she was looking for, a young smile, very aesthetically pleasant due to the use of these ivoclar library that gives the teeth a natural look and appearance. This is another case, 63 years old, has maxillary and mandibular complete dentures. Dentures are 7 years old. He has a reverse curve smile, a vertical collapse, and he's not happy with these dentures. He wanted to change the teeth mold and shade. Not much for the shade as much as for the shape of the teeth. For sure, I needed to open the vertical dimension. So I decided to go conventional, base plate and wax rims. And you can all do that too, but you don't have to invest into anything. You can just get to the base plate wax rims and then send it to the lab, and the lab takes it from there and digitize your dentures. Let me show you how I do that. I did the definitive impressions, put my cast, and then after they are set, I fabricated my base plate and wax rims. call him in, adjust Campo's line. I want the Fox biplane to be parallel to a line that goes from the ala of the nose to the upper part of the tragus of the ear. And anteriorly, I want that line to be parallel to the interpupillary line. And once I have these all set, then all what I have to do is adjust the vertical dimension of occlusion and grab eccentric relation record. Now, so far as you notice, these are conventional analog procedures that we all do for complete dentures. There's nothing new in there. But all what you have to do now is to provide the lab for some extra details to take you to the digital. Now, usually if you're picking up for the analog, you're picking up teeth, then you open the catalog of Ivoclar and pick up the teeth you want, and you tell the lab technician, oh, I decided it's a S72 for Phonaris, whatever. But in this case, what you want to do is provide the lab in, with the measurement of the papilla at the papillometer at repose and at smile. Now, you can download this prescription from the Ivoclar website in PDF format, and you can print it. It's an amazing lab prescription because it has all what you need to communicate with the lab. So in that area, it has the papillometer reading. You see the low lip line and the high lip line, and you can mark these in there. What you also do is take an inter-ala measurement. And what you do with that is you can do two things, is either use that measuring device on the back of the VivoDent SDCL shade guide, or you can use the traditional measuring device that Ivoclar has with the tooth selection guide. Now, at this stage, you've provided the lab technician with all the details he needs to set up the dentures. What he's going to do is going to digitize the impressions, the impressions you sent. Using the wax rims, he's going to mount the cast virtually. And then after that is select the landmark, determine the outlines of the denture. Now, you've provided all the information. He's going to pick the tooth library. And then what Lee does for me, once I approve the design of the dentures, he prints for me the tri-indenture. At this stage, what I can do is I can take that and put it in a patient's mouth and try it. Now, one thing about printed dentures is the surface texture of the teeth is not very nicely done because of the printing by layer. And then here there is sometimes some excessive polishing that needs to be done, which changes the morphology of the teeth. But they're good enough to check the fit, they're good enough to check the occlusion, they're good enough to check the border extensions, and they can also be given to the patient to take home if needed. One thing you want to do, if you give the dentures to the patient to take home, it's very important to let them know that these are brittle and they can break if they fall on the floor. Now, the good thing about them is they give an idea of the patient how aesthetically they're going to look at the end when they receive the definitive denture. Border molding, PIP could be done at that stage because I noticed, and Lee also did some research on that, and he found that these printed material, they do shrink. So what we do is we now do a PIP, and what we do is we also, if we have to adjust the intaglio surface, you do a wash. And then since I adjust also the occlusion, take eccentric relation record. So what he does is he rescans the intaglio surface, rescans the occlusal surface, and scans the bite, remount the dentures virtually, and finalize the dentures. They come back and they fit exactly how I provided him with the adjustment that I did on the printed trial denture. You see how they look? They look perfectly nice. The software provides you with a neck progression from the canine all the way to the molars, like you have in natural teeth. There's absolutely no opening between the teeth. It's an interdental closure, no food trap in that area. Aesthetically, the teeth look very pleasant. It's true they're monochromatic if you haven't used the CAD multi, but even though they're monochromatic, they have a low opacity, they have an excellent surface quality, and excellent morphology. Now, one other pre-appointment workflow is a single arch. Lady, 78 years old, wearing a maxillary fixed posture denture that she does not want to change. She's wearing a mandibular over denture that is a year old, but she's herself complaining of a vertical collapse. She goes, my face is collapsed and I don't like it. And then there's food getting stuck underneath. So here, what we did is just a traditional approach. What I did is I made a base plate and a wax rims. And you can notice here that the dentures are short on the retromylohyoid fossa, short on the buccal shelf, and all the flanges all around are extremely short. So what I did is I took some AccuDent XD trays. These are heat moldable. So I put them in water, hot water, and then you put them on the cast and mold them on the cast. You notice here that they were short of the retromolar pad area. So I decided to use some green stick compound to extend the length of the tray with a bottom molding with a heavy body PVS and a wash with a light body PVS. That stage, I put a cast, I fabricate my wax rims, and intraorally adjust the vertical dimension. I made a wash for Lee because I wanted him to see where the locators are so he can provide me a recess in the milled definitive dentures. At that stage, what he does is he sends me two things, a milled try-in and a printed try-in. And guess what? The patient felt more comfortable with the milled one, and it felt that it fits much better. And she didn't know what the difference was. The only problem here, there was a lot of overjet. So I sent the photo to Lee, and then over the phone, I was traveling, unfortunately, that day, but he sent me some pictures over the phone, and he adjusted the overjet, and I agreed on it. And he went ahead and finalized and milled the dentures. You notice here the difference in the retromylohyoid fossa area. This is how short it is, and look how long it is. The buccal shelf, and you notice the retromolar pad now is covered. Now, if you look here, this is not a scientific research, but if you look at how retentive these dentures are, and I haven't even attached the locators yet. So at that stage, I went ahead and changed her legacy locators to the RTX ones. And then you notice here that the recesses have been created because I gave him an impression of the intaglio surface when I sent him the base plate and the wax rim. PIP appointment, then I enlarged, created a recess for my housings to be picked up, put an undercut, then vented the whole thing, then used a chairside pickup material to pick up my housings into the denture. Now, once I do that, it sets, I take it out, clean the excess, polish the dentures, and I remove the black processing insert and put some blue inserts, and the patient is ready to go. And this is how she received the denture. The 4-appointment workflow is a totally digital workflow. At the first appointment, what you have to do is provide the lab with an alginate impression of the maxilla and the mandible. Of course, you have to try to acquire as much as possible of the anatomy of the jaws. If you don't, that's not a big deal, because the lab technician is going to send you a 3D bite plate that you're going to use as a custom tray to do a border molding and a definitive impression. And you're going to use some agnatometer CAD to do a Gothic arch tracing and get a good centric relation record. After which the lab technician is going to mill for you. In this case, it was a mill for you, the try-in dentures. You try them, and after that, you get the dentures to deliver. Let me show you step by step. So what do you need to start? The first thing, so you need a preliminary impressions, AccuDent, disposable trays, or any disposable trays you want, and you want an AccuDent XD alginate or any alginate of your preference. The second one, you want a papillometer reading and an inter-ala measurement. You want a tentative vertical dimension of occlusion by using a centric tray. And you also want two measurements, a bipapillary line reading and a campus line reading using a UTS CAD. And that's all what you need. So what you do is, for this lady, for example, 55 years old, completely edentulous, she has some bony exostosis. So I decided, and if you can see them here, so we decided to get these removed and make a maxillary and mandibular CD. Now, this is preoperative. So I raised the flap, filed the bone, and sutured. And once she healed, when I went ahead and got the disposable impression trays, mixed the alginate, and made a maxillary alginate and a mandibular alginate. And you notice I tried to acquire as much as possible from the anatomy, both in the maxilla and the mandible. Now the question here, would you send the cast or would you send an STL file? It doesn't make a difference. Now, you can either pour these alginates and send the lab these stone casts, or you can scan them and send the STL files. But if you do that, then all what you have to do is ship the centric tray because they want them to put everything together. At that stage, you're gonna take some putty and you're gonna take 2 scoops of the putty and base and catalyst, mix them together and make like a hot dog. And what you do is you take it and put it on the centric tray, you put on one arch, and then you keep going and you apply it on the opposing arch. And at that time, what you do is you put the material together and then you go intraorally and you have the patient bite at the tentative vertical dimension that you've established. How do you establish that? You start with finding what the vertical dimension of rest is. You subtract 3 millimeters. And then what you do is you can see here there's a dot on the nose and a dot on the chin. And then you have them bite on this and you measure to the exact vertical. Now, this is what you get. It's sometimes not very sufficient for the lab to scan to be able to superimpose these to the casts. What I do is I do a wash and I obtain a highly adequate surface for the lab technician to scan. At that stage, I'm gonna take a UTS CAD and I'm gonna measure 2 things. And before I forget, you also take a papillometer reading just to figure out where the length of the incisors is going to be. Then what you do is you do the papillometer reading. Now, the bipupillary line, and you're gonna put that to be parallel to a line that goes between the 2 pupillaries, and you're gonna measure that. So that's the first number that the software wants. The other number that the software wants is the Camper's line, a line that goes from the ala of the nose to the tragus of the ear. And then when you align that, you take the measurement, and this is the second number that the lab is going to need. So what you're gonna need is basically, if a patient is wearing a complete denture, you can go ahead and use a denture gauge and take some measurements to give an idea to the dental technician what the patient has. You definitely need the papillometer reading at repose and at smile. What you also want is an inter-ala measurement, that's for the mold. And what you want is 2 measurements, the bipupillary line measurements and the Camper line measurements. Now, once you have all of these, you're gonna send them to the lab technician, and he's gonna enter this data on his computer, and this is going to align the maxillary and mandibular cast exactly how you have them in the mouth. Now, at that stage, the virtual base plate wax rims are fabricated, and you notice there's also a place for the gnatometer. Now, you get the occlusal, the 3D bite plates. So what you want to do is try them, check the occlusion, check the vertical dimension, and then what you do is apply adhesive, do a border molding and a definitive impression. Then you're gonna put them in the mouth, maxillary one in the mouth again, check the midline and the high lip line. Then you're gonna take the gnatometer CAD, you're gonna attach one part to the maxilla, and this one that has the stylus, and the other part you're gonna attach it to the mandible in some recesses that are already milled for you, and then this one has a plate. Now you're gonna adjust the vertical dimension and you're gonna lock the pin so it doesn't move. And at that stage, this is the vertical dimension that I want. So all what I have to do now is once I establish the ideal vertical dimension that I want, I'm gonna go ahead and take another measurement of the bipupillary line and the Camper's line. And then these numbers are gonna be sent back to the lab technician one more time. That stage, I'm gonna take a Sharpie pen, apply it to the metal of the gnatometer CAD, which is in the mandible. And I'm gonna have the patient go forward and back, right and back, left and back, multiple times. And what this is going to create is an arrow. At the bottom of the arrow is centric relation. So now I know that when I take my impression, I want the stylus to be here. But because this is metal and the stylus can slide, how I'm gonna lock the patient in that position? What I'm gonna do is I'm gonna add a little sleeve that is provided. I'm gonna hook it with a screw and tighten it tight so it doesn't move. And you notice there's a little notch here that at the bottom of the arrow where my centric relation is. At that stage, what I'm gonna do is I'm gonna guide the patient so the stylus goes into that little hole and locks the patient into centric relation. Once this is done, all what I have to do is inject bite registration material between the two 3D plates. And I'm going to send everything to the lab. What the lab does is it scans the intaglio surface, scans the bite, designs the denture for you, and send you a trial denture. Once you try it, you might do some adjustments, take a eccentric relation record, and remember, if you adjust the intaglio surface, you have to take a wash. If you adjust the occlusion, you have to tell the lab that you adjusted the occlusion and take a new centric relation record. Now, in this case, I've adjusted the position of the centrals because they were too far out. So I grinded all the buccal, so I had to tell the lab that I did that. Then they rescan the whole thing and they design the dentures for you and they mill them. Once they mill them, they send them back for you for delivery. And again, it's a traditional delivery, PIP, and then check the occlusion, and then you give the patient information to maintain. Now, what are the advantages of CAD/CAM complete dentures? For the dental technician, dentures take a shorter production time. They have less lab steps. There's no plaster, no articulation. It's a quicker model analysis. So just you have to move the mouse, pick whatever you want, and move the whole arch. You don't have to deal with wax. You don't have to deal with instruments. It's a faster teeth setup and gives you a more accurate and a better quality complete denture. Now, for the clinician, there is a reduced number of patient visits. You notice that you can take your appointments from 5 appointments to 3 appointments. And there's less clinical chair time that is needed, and then opportunity for a more cost-effective complete dentures. Also, there is a repository of digital data for more rapid fabrication of a replacement denture. Now, remember, the lab has designed virtually your dentures so they can keep them. Now, God forbid the patient loses their denture in a campfire, in a barbecue, or in a hospital. You just have to call the lab and have them reprint another one. Also, dentures have a superior fit to conventional process spaces, and they have a reduced cost. Now, maybe not a reduced cost for you as a clinician, but definitely for the lab technician. The advantage also is that it has a superior strength, improved physical properties of base material, less residual monomer, and a better density because the blocks are made under 5 to 6 bars of pressure. The material is extremely dense, and there is a reduced potential for base material to harbor bacteria. The disadvantage is there is a need to learn some new clinical procedures. The need to use scannable, dimensionally stable, temperature-resistant impression materials. Now remember, you're going to have to make an impression, put it in a box, and send it to a lab technician. And depends on the area where you live. Like if you live in Southern California with boiling hot, or in Arizona or Nevada, you have to have a material that is stable. And also, there is a clinical remount that is still required to adjust denture teeth if they are bonded. Now, if the teeth are milled, you don't have to worry about a clinical remount. But if your teeth are bonded, you need to do that. Just important to know that there are 7 keys to a successful digital denture. Acquire an excellent definitive impression, get occlusal vertical dimension that is appropriate and adequate, know how to get a centric relation, know how to evaluate the lip support, get a good midline, know how to get the anterior teeth size, and how to find the incisal edge location. And once you have all of these, if you master all of these, you have no problem going into digital dentures. I invite all of you to think outside of the box. I know this is new. This takes some while for us to kind of learn the technique and the procedures. But once you learn it, it gives you a great favor, and it gives your patient also a great favor because they get better fitting dentures, better looking dentures, and stronger dentures. With this, I want to thank all of you for your kind attention. And if you have any questions, you can email me, and I'll be more than happy to do that after the webinar. But meanwhile, I can take some questions from the audience. Now, the first question that I have is from Jen. He asked, does the software suggest certain teeth mold based on landmarks and measurements? No, the teeth does not suggest any teeth mold. You will pick the teeth mold according to the measurements that you made, the papillometer reading and the inter alar measurement. That's what you need to do. to figure out the teeth mold. The software does not give you any suggestion. The second question is from Sadr. He's asking, these dentures are you making an immediate complete dentures, or they are final complete dentures? Well, in the first two cases that I showed you, these were immediate complete dentures. They will need to be relined. And that's why I stress the fact that milled dentures are much better than printed dentures at that stage, because the milled dentures can be relined with PMMA, cold cure PMMA. Unfortunately, the printed ones cannot be relined with any material. But to answer your question, yes, these are immediate dentures. He's asking also, if it is immediate denture, how long after you reline it, or what procedures you do after delivery? Now, after delivery, what you can do is apply a soft reline, like Co-Comfort, like any other materials, any material you use is fine. But what you want to know is after 6 months, you can do a hard reline. So what you do is you do a traditional bottom molding definitive impression and send it to the lab to reline it. Shannon is asking, how does the lab cost of digital dentures compared to classic fabrication? Excellent question, Shannon. The lab charges you the same amount of money to make either a digital or an analog. Now, you have to understand that for you as a clinician, the cost doesn't make a lot of difference for what you pay for the denture. The cost that you save is what you save chairside. Instead of a 5 appointment, you have a 3 appointment. This way, how you save money. But now, of course, the lab, because they mail, they're going to charge you premium cost for these digital dentures versus the analog. So you have to expect that you pay a little bit more. Some labs charge the same cost for digital and analog. Some labs charge a little bit more for the digital. So you have to investigate. Another question is, like, how do you repair a milled denture tooth? That's a very good question. The material is PMMA, and what you can do is you can use cold cure PMMA, the same shade of the teeth that have been milled, and you can adjust that. We've tried that. We broke a denture with a hammer just to see if we can fix it, and we found out that we can. Now, if the teeth are printed, forget about it. You will not be able to fix them. They need to be reprinted. Another person is asking, are there now scanners used for the impression stage? The answer is yes. You can scan the soft tissue. It takes a little bit of a know-how. It takes a little bit of a learning curve. It's not a rocket science, but it's going to be there in the future. It's going to be even more. We've done many cases where we scan the soft tissues and we've made dentures from them. Yes, you can do that. Another question is, how is the posterior palatal seal developed? Excellent question. Because the material does not shrink, the milled material has pre-shrunk. It's a block of material that has a PMMA material has a pre-shrunk, and it's under 5-6 bars of pressure, so it's a very hard material. The material does not shrink, so there's no need to create a posterior palatal seal. Conventionally, with the analog dentures, the reason why we had posterior palatal seals is because you wanted to compensate for the shrinkage of the material. And that's why we had the posterior palatal seal or the post dam, just to close that area and seal it. But with the milled dentures, you don't need that. Another question is, what we can learn more to become proficient in these new techniques? Excellent questions. What you need to do is have an open mind and be willing to learn new things, and don't be shy to ask questions. You're not supposed to know everything, but what you can do is ask people that have done it, and you can little by little go and I suggest to go start with the conventional up to the wax rims and take it there to the digital. Another question, can we realize only maxillary or only mandibular? The question is yes. What software is used by Ivoclar? 3Shape is the software that uses that Ivoclar uses to fabricate these dentures, all the dentures that I've shown you. And then the last question is, do you recommend Ivoclar over the other manufacturers listed earlier? Do you have any thoughts on the new Lucitone resin from Dentsply Sirona? Yes, I do. Now, all these systems have the advantages and disadvantages, but what I can share with you is that Ivoclar and Avident, as far as I'm concerned, it's a personal observation, are the two companies that provide you with quality dentures. I'm not saying the others don't, but the process to make the dentures are easy and predictable. Now, regarding the new Lucitone, the new Lucitone just was launched 3-4 days ago at the IDT meeting in Atlanta. It's a promising material. It's pink rather than red. We don't know anything about the physical properties yet. All what we know is the claims that the company has made that the material behaves very well when it's in the mouth, but we have no proof of that yet. The only drawback, as far as I'm concerned, is that the teeth are carded teeth that are bonded, the single teeth that are bonded. And for me, these are not going to be placed in the same way that the dentures were designed, so they will require a clinical remount. So I think I've answered a lot of questions. So that's it. So good night, and hope all of you enjoyed the webinar, and hope to see you in some other webinars and get the chance to answer some other questions.